Okay, so let's start talking about OOP, object-oriented programming. um, OOP. That's a lot. It's not only is it a way of way to think, way to structure your application. It's a way to, you have a textual representation of your problem, and you immediately, it's so natural. Immediately you start thinking in terms of classes and objects and methods inside. Let's say I'm telling you, you're supposed to create a salary calculation system. And for each employee, you should be able to calculate the salary. And immediately you start to think about, okay, which are the nouns, substantive in Swedish. Okay, so we have employee, and all the nouns will become. I really hope nouns is the correct. I need to translate. Yeah, it is noun. Okay. Then I will continue calling it noun because that's the correct name. So all the nouns in the text representation will typically become classes, or that could be, okay, so you should have a register of all hockey teams and their players, and statistics of all the games. So immediately you see three classes, right? The team, the player, the game. That's classes. Sorry. It's really natural, and that object-oriented programming is kind of the only thing that hasn't changed, since actually, let's go here. It started in the 1960s. Even before ancient C was created. It's so old, but it's still really. It's still going strong. It is. After all these years, because it's so natural, and it works. Even though, when we talk about, some new languages, actually not even new. Python. We also have Go. Especially, in Python, yeah, you can use object-oriented programming. You can use classes and so on, but you also have the notion of scopes. Modules, and a module kind of is another level of abstraction, which can often be used instead of classes. Maybe I shouldn't say we, but I include you as well in the Golang community. In the Golang community, we often use modules and folders instead of classes. And actually, Golang isn't even object-oriented the way we think about object-oriented, but that's another story. Let's go back. It is really natural, even though some of the things we will talk about here is, yeah, it's possible to take object-oriented programming with encapsulation, with polymorphism, with inheritance, with abstract classes and so on, to the extreme. It's possible to take it to the extreme. Sometimes you don't need to do that. We have the choice not to do it. But in some of the newer languages, like Golang, it's not even possible to use things like inheritance and so on. So it's a subset of object-oriented programming. But still, the concept, when we go from a textual specification to code, that's it's so natural. We can think of object-oriented programming as a way to lump together multiple properties into the same thing. I mean, say we are creating a salary calculation program application. I mean, if you have employees, an employee probably have a lot of properties, so to say. Or I mean, it has a name, it has a monthly salary. We need to store. I mean, all the things we need to store. We can't create variables for, salary for employee 1, salary for employee 2, name for employee 1, name for employee 2. That's impossible. So it's a way to lump together multiple properties. We also use it for containments. I will show you that. How a class could contain another class. I mean, yeah, the hockey team, right? The hockey team has a name, and it has a maybe a founded year or something, but it also has a list of players, right? So it contains another class or a collection of other objects. Actually, I will talk about objects soon. OOP is also about constructors and destructors. And I will talk about that. I mean, we typically use constructors and destructors to ensure that the object is always in valid state. I will talk about that more when talking about encapsulation. That's kind of the same thing. We want to always ensure our object is in an valid state, and I will talk about when can it be in an invalid state. Yeah, let's just say we have a person and we have birth year. So if I set the object object.birthyear equals to minus 51. I mean, that's now that object is in an invalid state. So I mean, we will work a lot with validation, and when it comes to OOP, a lot is about ensuring valid state, and even creating. You shouldn't even be able to create it in an invalid state. So that's where constructors come to play. These structures are also really valuable, since we will later talk about resource acquisition is initialization. I mean, the thing, the mindset, in how C++, this is how C++ has become as good language as, I mean, Java, C# when it comes to memory management. I mean, there is a lot of secrets in here, or should I say, and destructors plays a very important role there. OP is also about inheritance. So I mean, we will create hierarchies of objects, classes actually. I mean, so we have animal, and we have a dog, and we have a cat, and they both inherit code and data from the parent class. Polymorphism, that we will also talk about that. So we can have, I mean, it's kind of related to overloads, but still not. More the other way around, I think. So we should see overloads as a way to accomplish polymorphism. But when we talk about polymorphism and objects, we will talk about virtual functions, and that will also bring in things like abstract classes. I mean, in a lot of programming languages, we have interfaces. In C++, we have abstract classes, which could be more or less abstract. I mean, an interface is typically supposed to be, I'm saying supposed to because some weird things are happening. I mean, in C# interfaces now can include code as well. It's yeah, but anyway, I mean, an interface is supposed to just to don't contain any code, but abstract classes can. I mean, there could be some code and data, and still it's an abstract class. All right. So as you can see, this is a lot of weeks actually, and those things we will talk about further on. So for now, let's start by. I mean, let's try to start by just looking at it this way, a way to lump together multiple properties into the same thing. Yeah. Okay. Yeah, and this is a cool. We will also do containment, and we will at the same time have a look at. I mean, I got the question about how can we return an array of objects. And I said we shouldn't, because we have the problem of who owns the heap allocated data structure. But we will do it with a vector today. We will create maybe a team containing players, yeah, and the team, will have a vector with players, and we will return that vector. And so on, and it's I mean, this will lead us into move semantics. That's so cool, because as I talked about how things are always copied by value. I mean, even pointers are copied by value because it's a copy of the pointer. But anyway. I mean, when we have larger data structures like a vector with hundreds of thousands of persons or something, it's not that. I mean, how should we ever return such an object and avoid multiple copies of it on the stack? So we have a thing called move semantics. I mean, it's so cool in C++, from C++ 11, I think. Anyway, so yeah, this is the background. I already talked about it. So we try to design and set our architecture through classes, and it's also about code reuse. So reusing code, we reuse a class instead of saying we reuse a function. So we reuse classes. That's another level of abstraction. Okay, so let's talk about classes versus objects. Okay, so we have class in Swedish, class versus object. Anyway, classes. We should look at classes as a blueprint, a ritning, a blueprint of a house. And then, I mean, we could use that blueprint and create 1 or maybe 10 houses. All the houses look the same, as in they all have the same properties. I mean, the same number of rooms, the same number of, but they still are different objects, right? I mean, there are areas where you know all the houses look the same. It's not the same house. They look the same because they are created from the same blueprint. But I mean, and they can have different values. I mean, like colors. That's a value. We all have a property called color, but we can have different values. Okay, so a class then, it consists of data, or we could say I mean, as usual, everything we talk about has multiple names and so on. So attributes or member variables or properties or whatever you should call it. We have methods, or we can call it functions. So that's functions inside the class. We have, as I said, a constructor and a destructor. There are special functions. I will not talk about that today. And we also have access modifiers, private, protected, and public. And I mean, that has to do with encapsulation. I will talk more about that later. But we will touch it already today, but not so deep. All right. First of all, as usual, I mean. Of course, there are two more or less equivalent ways of doing things. That's us in a nutshell. I mean, so in C++, we don't not only have the keyword class, we also have the keyword struct. So let's talk about a struct. If you ever programmed in C, yeah, old C. You have I mean, a struct is exactly what I'm talking about here, a way to lump together multiple properties in the same thing. That's it. I mean, it's not more than that. But in C++, a struct, the keyword struct, is actually, and I will show you, it is, I mean, it will be the same as a class, and that's so weird. So a struct in C++ can have methods as well. As you can see, okay, so we have x and y, and we also have a function. I mean, and we could, if we'd like, just switch struct to class, of course. There are a few differences between struct and class. They are the same, and I will show you what I mean by that. But there are some differences. So in this struct foo, this x will be public. If I change this struct and put in class instead, then this x variable won't be accessible from the outside. It will be private. So the default access modifier is different. So it's private for a class and it's public for a struct. But that's pretty much the only difference. I will show you some code. Finally, we will look at some code. Okay, so what I meant was, let's create an object. As you can see, I'm able to access the x. Ah, sorry, x is not the best name. Like this, I meant. So this is fine. We could also, of course, use like this. If I now change the foo from being a struct to a class, you will see that this is inaccessible. So we can't access. But I mean, we could then put public. Sorry. Yeah. Okay. There it is. So I mean, that's one of the differences there are, and there are not so many other differences. Seriously, I mean, have a look at this here. So there is, I mean, or in all programming languages there are possibilities to, I mean, read metadata, read about the types and get the current type for a certain object or something. So here we can call a function called isClass. isClass is I think it's in utility. Otherwise I wouldn't have included it. I think it should be is. maybe, okay, maybe it's included further on, but anyway. So there is class, and as you can see, now we're starting to, I mean, this is getting really, really advanced actually. As you can see, ooh, so we have it. It's a template, generic, or in other languages. So it's but we also have, what's this? This is a static class variable. I will talk about it later. But anyway, we could ask a certain type whether it is a class, and it will return, guess what? Yeah, it will return true or false. And as I print that out, I mean, guess what it's going to print out. I mean, it's yeah, you can see it here. Actually, I will now I have added end line as well, so let's run it one more time. So I mean, what we get is 1 and 1, so they are both classes. They are both classes. Okay, so let's just finish up structs. Actually, I'm gonna, because when are we supposed to use structs? I would say, at least in this course, you could always use classes. I don't see, as I see it, there is, at least to me, but it might be I'm coming from other type of languages, or maybe you don't see it like I do, but to me, the big difference between a struct and a class is actually semantics. I mean, I use a class when I have, I mean, when there is a class, I need to have methods, and I need to you know, real OOP. But sometimes I just, okay, so we want to throw some data back, or between two classes, you know, DTOs, data transfer objects types. So it's not like there's a lot of things going on. It's more like a, yeah, like in Python there is a data class. I will show you. And I think this is I mean, it's used to just, actually it is a regular Python class, as you can see, but it's designed to only hold data values. That's how I see structs, but that's me. You are entitled to your own opinions, of course. All right, so with that, I'm gonna leave structs. Yeah. So let's go to classes. So we will use classes. This is a class, and as I said, I will talk about encapsulation, because I often take the role as a code police, and kind of like, okay, bad code, good code, what coding policies should we have, and so on. And access modifiers are actually, I mean, it's one of the most important things to ensure valid state, and this is then called encapsulation. I'll talk more about it later. Now let's just follow along. So we have a class could have a private variables, right? So in this case we have a point, and I mean a point on the screen. It has an x and a y coordinate, and as you can see, we also have some functions. Also, this was I don't know how I'm meant to be able to modify it. Set x, we need to, like this, okay. Okay, so we have functions as well, and the functions are accessible outside class. Actually, it's not a function, I mean all things under the public. So as you can see, we have the public part, and then a lot of functions and methods actually than it is. But I mean, this could also be fine. So I mean, we can very well have global, not global, but public properties in a class. Anyway, so it looks like this, and the tip for you: don't forget the trailing semicolon at the end. Okay. So let's create the class. Let's create this class, and we will do it. I mean, we will do it. We will try to. I mean, try to follow. Maybe not the best, but at least better practices. So let's create a file called person.h. And I will then create the safeguard, right? Like this. Sorry. Okay, I will do this first. Okay. No. It's not working. It's not working. Okay. What I wanted to do was copy and paste. All right. So this is what we should create then. And I mean, I will immediately start by separating our class. I mean, the school examples when it comes to C++, it's always where the code is. I mean, the definition for the methods are inside the class, so to speak. But we rarely use that. We try to. I mean, we try to use header files and CPP files. So I will immediately do it the correct way, or how I should put it. So we have a class, and it's called person. And a person then, and remember the trailing one. Yep. And let's create some private variables. And each will have an age. It will have a string called first name. It will have a string called last name. I meant to do that. It will have an int birth month. All right. As you can see, we need to include string. And as I said, this is the main reason why we are safeguarding. I should also using namespace like this. This is, I mean, whenever we need something, we just include it. And it will never be included more than once, because it could be like a recursive includes them, as long as we have this. I mean, as you can see, we only include it if it's the first time this is included in the chain of includes. Whew. All right, let's do some. Actually, no. Let's start here. Let's start here. Let's set the public. All right. So we only have a header file now. Now I will show you how to create an object, right? Because this is now just gonna include it. This is now blueprint. So we could create a new one. And I will create it on the stack. Actually, let's test function. Let's do like this. So we create the function in order to create some scope, so our object will will die sometimes as well, because now we create an object. Yes. So I mean, it's as you can see, it's like, okay, int e or whatever. So the data type and the variable name, we could call it Stefan maybe, and we could then access the different properties by using the dot operator. So Stefan.h, Stefan.birth month, first name, last name. All right. And now we are, yeah, I mean, we could, what should we do? I don't know what to do with me. I have no idea. I'm completely hopeless, but let's yeah, like this. We need to use me as to do something as well. And what will happen here is, oh, now it's kind of I don't feel so good about it. I mean, I will kind of die as soon as we leave this scope. But anyway, let's run it, and we will see what's going on. I just want to show you like this. Okay, so as you can see, the Stefan is a variable, and that variable by itself, it's an object actually, but I mean it's a variable, and it has all the different properties. As you can see, they have been they are not set. So I mean, in this particular moment, right now, could we say that this object is in a valid state? I don't think so. Because I mean, there shouldn't be anyone with a birth month of 0. Maybe there could be someone without the first name and the last name. That might happen. I mean, we didn't give name to our son. I mean, it took a few weeks before we decided. So I mean, it's possible for someone to exist without a name, but it might not be. I mean, the birth month must always be set, I guess. I mean, that depends on the actual application. I mean, it depends. Okay, so to calculate the salary, we really need to have like a birth date or and how many hours they have worked. They are mandatory. So things that are mandatory, we need to treat and handle in another way. I will talk about it, not today, but we will. That's what a constructor will be used for. Talking about valid state. It's also possible to, and I mean, this is what I was going to talk about in the next for the next week. I mean, encapsulation and valid state and so on. I mean, this is possible. Oh, that's not. I mean, whose responsibility is it to ensure that the object is in a valid state? Actually, it's the one creating this class. So we need to redesign this so it's not possible to put it in an invalid state. So we will use getters and setters and so on, but not now. Not now. Okay, so we have this object. Let's create another object. Let's create let's create another object. Okay. So now we have created 2 objects. That's great. I mean, now it's possible to create. New customers or whatever when we kind of when we have gotten a new customer or whatever. But the problem is, as you can see, this is very static. I mean, if we were yet another in our family, I would have to go in here. Okay, so I need to create another one. So we will, we will look at creating that more dynamic data structure and so on, but not right now. Let's remove this because what will happen now? Actually, let's talk about this variable. Where is it placed? Is it placed? Where is Stefan placed? Stack or heap or both? And the thing is, both in a way, but I would say primarily on the stack. So Stefan is placed on the stack. However, as you can see, when the compiler allocates memory on the stack for this data structure, it will need to know, okay, how many bytes do I need to reserve on the stack? And how many bytes does it need to reserve? Well, it depends. I mean, it depends on how many and how large our how many variables and how large they are. So I mean, it will be probably 8 bytes. And what will this be? So a string, as I said before, a string is placed. A string is placed both on stack and heap, because a string can always it can resize. It need to be able to reallocate and shrink and so on. And for that to happen, it can't use the stack for it. It need to use the heap. And one of the cool things are that, I will talk about memory management and so on, and I have told you how hard it is, how easy it is to fail miserably. It's so easy to forget to return. So I mean, is there a risk? What would happen if we create a string? Okay, we create a string. Let's say now that I do actually this one won't even compile, I think, but anyway, maybe it will compile, I'm not sure. I can't remember if anyway, but I mean, when this line happens, it will throw an exception. And didn't I just tell you that string variable, there will be a heap allocation? So with that said, when this happens, is there a risk that this one, actually the heap allocated part, is not returned to the returned to the system? they need to be destructed. And the cool thing is about, I mean, this is actually, it's a beautiful, I will talk about it more in details later, but we have the notion of resource acquisition is initialization. So I mean, and it's really abstracting away the fact that there is a heap allocation inside the string. We can see it. We can just see it. We can just consider the string to be stack allocated, because when the string is deleted from the stack, then there will be a special function called, and that's the destructor. Yeah, and in the destructor, the string will delete or free the heap allocation. So I mean, it's that's why we have destructors. That's why we have constructors also. So we're able to initialize, and we're able to return things, and it's I mean, it's very well thought, and I mean, it really differs from a GC enabled languages, garbage collector enabled like Java and C#. So this is different, but it's, I mean, we achieve kind of the same thing, but more controlled, actually, I would say. So as you can see, the string is placed both on stack and heap, which means that whenever we go out of scope, the strings and everything will be deleted. How can that be? I mean, we haven't even created a destructor. That we don't have to. I mean, there is always, I will talk about destructors, but not today. But I just want to say, these are cleared because there is a default empty constructor which will remove all the containing properties. Anyway, we will talk more about destructors later, but as you can see, I mean, it is a difference in how we see things. Maybe it isn't. Maybe it isn't. I mean, maybe you just, of course, it's like that, or actually, of course, of course, you expected that result. You did, I think. If you ever programmed like Java, C# or any other language, I think you expected me to say that, okay, of course, when we leave the scope, this object will be completely freed. But actually, it's the way of getting there is completely different, and from other languages. So we don't have the garbage collector. We have the destructor, which will, I mean, it will free when we leave the scope and so on. Okay. So this one is placed on the heap. Sorry, or the stack. Let's create an object on the heap then. So I will create test function 2, and I will create an object like this. So here we have a pointer to, and I will talk more about pointer in a few weeks. All right. So we have a pointer to a new person, and I think this is how we are used to, I mean, create instances, create objects from classes by using the keyword new. If you ever program C# or Java, the thing is to access, since this is now Stefan isn't a person, it is a pointer to a person, which is regarded as a different data type. So we need to, we need to access the different parts by using the arrow. Actually, it's not the. I hope you haven't used JavaScript. Then this is an arrow function. This is an arrow, but it's with a single one. Okay. All right. Okay. Let's run this. And I will afterwards I will tell you what we just created. We created something bad. All right. Was it so? Didn't I even? All right. Yeah. As usual. I forgot to debug instead. Okay, so at least we can see it's working, and it's not a problem. Now the program will quit, but what we have created here is a memory leak. We create something on the heap, and it will be left on the heap. I mean, it will be just there. The memory location will be allocated and marked as used. So no other variable or something could use it. So it's not like in C# or Java. It's not. I mean, in Java or C# we have this garbage collector, and each object keeps a reference count. So I mean, each object created in Java with new or C#, each object will keep a reference on how many variables are pointing to me at any time. Because I mean, we could as you know, but what I mean, how many? Yeah, I mean, we could we could have a pointer like, okay, so Stefan is new person, and then we could have a variable called the coolest person, and we could say it's Stefan. So now we have two variables pointed to the same object in memory, and that object in memory will have a counter with 2 now. It's pretty amazing. And when that counter goes down to 0, then not immediately, but then the next time the garbage collector kind of so the garbage collector will scan the memory for objects and see, okay, so how many references do you have? You have 3. Okay, I won't remove you then. But you have 0 references to I will remove you and free the memory and return it to the system. Okay, so this one is but I mean, aren't we supposed to do it like this? Actually, we aren't anymore. This is how we programmed in 1995 or something. We will instead use a concept called smart pointers. And I will just show you. This will be the last thing I want to show you. So let's. I mean, the correct usage of this would be we need to delete it. So in C we have alloc, malloc, and realloc, and free. Here we have new and delete. So each time we new anything, we have to delete it. All right. but maybe it's hard to remember it. It's really hard to remember it. And I mean, in this case, if it crashes, this line, if it throws an exception, I should say, then this line will never be called, and that will be a memory leak. So what we use is we combine what we know already. We know that, and I will go into detail, but we know that when an object is created, there will be a call to a constructor, and when it's removed from the stack, it will be a special function called destructor will be called. So we will do just like the string does it. I told you that the string allocate one part on the stack, and it also has a heap allocation. And the cool thing is, when we leave the scope, the destructor of the stack thing will be called, and therefore it could release the heap part. We will do the same thing. So we will create, first of all, we will include a header called memory. And here we have something called a smart pointer. So, and I mean, we try to start using auto as much as possible. Okay, so we use something called a shared pointer. There's also a unique pointer, but I won't go into that right now. And here we say it's a smart pointer to a class of type person. And to the constructor, we send the new person. Like this. All right. So as you can see, I mean, we really wrap. This is, this will now, let's look at this. This will now, okay, we won't see it as clear as I hoped we would see it, but this will be stack allocated, just like the string. So it's an object placed on the stack, and inside it we have a pointer to something. And the cool thing is, when we go out of scope, it will call the destructor of this one, and I mean this one would then just call the destructor, the delete for this pointer then. Okay, so other than that, the code is exactly the same. As you can see, this is yeah, I mean, you can see that there are lots of cool stuff here. This shared pointer data type, it has a lot of functions. It also, and this is cool, it overloads an operator. It overloads the arrow operator. I will show that also, but not today. So I mean, that way we are able to get properties inside this one by this class, which is not even related to it. So it's really cool. And what we have created now is this is safe. This is safe. We do use heap allocation if we want to use that. I will show you that when we get to use the algorithms and data structures in STL. We kind of strive to, actually we almost always strive to use as little heap allocation as possible and use stack allocation instead. And the secret behind it will be, I mean, you might think that's not even possible, but there is the move semantics, which will help in reducing copying things. Okay. Actually, I will stop this right now. I will just have a look at if I have forgotten anything important. If I have, I will talk about it in the next video, so that doesn't matter. Okay, so we have, yeah, I mean, I haven't even talked about the move semantics, and yeah, that will be perfect. So in the next video, I will instead of using a person, let's create a team, and we also have a player, and we should also divide them in a header and CPP file.